I'm Amit Kumar Pal. Currently, I'm a third year undergraduate from IIT Kharagpur, and I joined IIT Kharagpur in 2020. And my main engineering branch is electronics and communication. And today, I'll be discussing about this chapter, which is a core chapter of mechanics for your JEE preparation. So this is basically your laws of motion. So basically, all the coming chapters will be applying the principles of laws of motion in some ways. So it is important to understand about this chapter. So I'll be giving a brief description of this chapter, and after that, I'll be moving to the exercise part of this chapter, which is quite interesting. So yeah, so I'll be starting with a brief theory. So the laws of motion is basically based on the three main laws of Newton. Out of which the first one is basically described about uh, condition of the body that states that a body remains in the state of motion as long as any external force doesn't act on it. दैट मीन्स कोई बॉडी अगर मोशन कर रही है तो वो मोशन में ही रहेगी। अगर वो स्टैटिक्स है तो वो स्टैटिक में ही रहेगी जब तक उस पर कोई एक्सटर्नल फोर्स नहीं अप्लाई किया जाता है। सो लेट्स से दिस इज एनी बॉक्स एंड it is moving at some velocity v. So it will keep on moving with the velocity of v unless you apply some force to stop it, or you apply some external force to increase its velocity. So the first law states the same that you cannot change the state of motion of the body as long as you don't apply any force. Means you can change the state of motion of the body only when you apply some external force on the body. So yeah, the same is stated here that is the external force is required to keep the body in a uniform motion. So external force is not required to keep the body in a motion, because if a body is in a motion, it will keep on moving in a motion. So this is the same law of inertia that states, and after that, the important law that is presented in this chapter is the force law that relates the force acting on a body with its mass and acceleration. So acceleration is an important property of body, and that basically describe about some speed of the body or the momentum possessed by the body. So the second law of motion basically mathematically relates the force acting on a body with the velocity of the body. That states that the force acting on a body is equals to, or you can say it is directly proportional to the rate of change of velocity. So basically, force is directly proportional to the rate of change of velocity. So we can say that this is directly proportional to dv by dt. Okay. What is dv by dt? dv by dt is basically small change in the velocity that will produce the force. So the second law states the same that if body is moving and you are changing the state of the body, like you are applying some force and this is causing some change in the speed of the body. So this force will be proportional to the rate of change of velocity. So if we remove the constant terms of this expression, so this becomes a force is equals to k times acceleration. Because what we have learned in the chapter that is basically kinematics, the rate of change of velocity is also known as acceleration of the body. Okay, so the force can be written as k by m, and this k is nothing but the inertial property of the body, and this is inertial property of the body is basically mass of the body. Okay, so yeah, this is the mass of the body. So this is the same that is stated in the second law of motion, and if you come to the third law of motion, so this is very simple law, but it has a lot of application that basically says that Force does not occur in a single pair, but it occur in a pairs. What we mean by pairs? So by pairs, we actually means that if you are applying some force on the body, it tries to resist the force that you are applying on the body. So that means that that body also apply some force on you. Okay. So the best way to understand this is uh, basically taking some examples. So uh, I hope everyone of you must have seen the rocket launcher. Okay, so what happened? This is some rocket launcher, and what happens when it moves upward? Okay, so how does this move upward? This doesn't move upward on its own. So if you have carefully observed in some movies or in a real life, this basically ejects the gases in a very high momentum. Like it ejects the gases in a backward direction at a very high speed. So what happens? And due to changing the momentum of the gas, the momentum of the gas changes in a downward direction. So to resist that momentum, these gases also apply a force on upward direction on a rocket. So this is basically an external reaction pair. The gases eject in a backward direction, but to resist that change, they apply a reaction force on the rocket in the upward direction. So this basically causes the lifting of this body, and this body moves upward direction. So yeah, so that is basically third law of motion, and this can also be understood as let's suppose let's suppose this is some wall, and you are applying some force on this wall. So what happens according to the law of motion? If you are if you are applying some force on body, then it should change its state, like it should start moving. But you know that the wall doesn't move on its own. So how does it doesn't move? So it basically doesn't move because the wall also applies some force on you in backward direction. So we can denote it as reverse. Yeah, so to denote it by a reversal, so you are applying force in forward direction. The wall applies same reaction force in the backward direction. So basically, these form action and reaction pairs, and neither you move nor the wall moves. Okay, so yeah, so this is basically the third law of motion, and third law of motion basically finds a lot of application while solving the questions because when you apply some force on the body, it also applies some reverse force. So you can calculate the force in this way, what force you are applying on the body or what force the body is applying on you. Okay. And if you move to there is another important concept that is equilibrium of the body. So in a lot of situations, what happens, the system is static, still the forces are acting on it. So you can't say that if a system is static, no forces are acting on it. Let's suppose these this is some wall, and these three forces are acting on this body. Okay. Yeah, so if these are three forces acting on a body, so uh, this ball doesn't move because what happens? These three forces are acting in some equilibrium manner. What do you mean by equilibrium? By equilibrium, we means that the resultant of all these forces is equal to zero. Means the vector sum of this force makes the net force on the body equals to zero, and that's why the body doesn't move. So how can this three forces be equal to zero? So if you try to visualize these forces in some way, like resolving it in a three direction. So let's say this has two component in this direction, and then this has a two component in this direction. Okay. So what happens for the net equilibrium? Let's say this is F1. So for the net equilibrium, the net force on this body should be equal to zero, right? So what happens? This horizontal force and this horizontal force basically cancel to each other, and finally these vertical force cancel this vertical upward force balancing the two downward vertical forces. So This makes the body basically in equilibrium. So what happens if the forces are acting, but they don't cause any acceleration because net force on a body equals to zero. So this is basically an equilibrium condition. And yeah, that's all. And if we describe more about circular motion, so since the important thing about circular motion is that yeah, 1 minute. So the important thing about circular motion is that even if the body is moving with the uniform velocity on a circle, you might confuse that the body is at rest or no force are acting on a body. Okay. So, but if you try to visualize the second law of motion carefully, this state that F equals to m times dv by dt. Okay. So basically, this is a vector notation. So what happens? The force vector is equals to mass into rate of change of velocity vector. So here the velocity might be constant, but if you observe carefully, this is the velocity at this instant, and after some instant, the velocity becomes this. Okay. So if you notice that the velocity vector is changing, okay, like this has changed this much, okay. So this is the same thing that even if the velocity is constant, the vector is changing. Okay, so some force is necessary to keep the vector changing, and the same force is called the centripetal force. So the best thing about the centripetal force is that it always acts along the center of the body, means the center of track. Let's say you are moving on some curve this way, okay, and you are at some point this way, so you might confuse what is the centripetal force acting on this path. So still the centripetal force is acting in here, and you can visualize this. You can visualize it in this way, like if you draw some circle this way. Okay, so this is basically what we call as centripetal force because this velocity vector is at this point is in this direction. After some point, it goes in this direction. So some force is needed to change this velocity vector, and this is basically equal to centripetal force. And this can be obtained by drawing some imaginary circle at that point, and the center of that circle is basically the center of centripetal force. So yeah, that is centripetal force. And if we if we mathematically say about the centripetal force, so this is equal to F equals to m times and dv by dt. And if you do some geometry, then you will conclude that this force is basically equal to uh, yeah. So this force is equal to F equals to mv square by r, where v is the uniform velocity and r is the radius of curvature. Okay. So this is basically radius of curvature, and this is uniform velocity. So this is basically case when the object is moving a uniform velocity, but this might also change if there is some acceleration also on a circular track. So basically, then two forces at that moment. One is a centripetal force, and other is basically your tangential force that helps in changing the velocity along the track. Okay. So that is about the centripetal, that is about circular motion, and we'll see more about this while solving the problems. So this will make it more clear. And yeah, so and then comes about the friction forces. So friction is another important concept because in a lot of problem we encounter the friction forces. So what happen in a friction force? Let's say any object is moving on some track. Okay, let's say this is your wedge, and some object is kept here. Okay, so the natural tendency of this object is to fall down along the track. Okay, if the incline is not so steep that it doesn't topple the block, so the block has a tendency to slide along the path. But still, you'll observe that up to the certain limit of this inclination, the block doesn't move at all. So what happens? Uh, what is the another force that is keeping this object in a static? So basically, there is a one force mg acting on it. So one of the component of this, that is mg cos theta, acts normal to the surface, and another force that is mg sin theta. Yeah. So this is basically acting along this direction, and yeah. So to oppose this force, there is another force that basically act as a opposing force. So this force basically oppose the direction of the motion. So this same force is called friction force, and this force is equal to uh, basically the coefficient of friction and the normal force that is present on the body. So this is basically force acting on the body anti cos theta. So to oppose that force, the surface also apply some resisting force, that is mg cos theta. Okay. So the same force act as a reaction force, and so to manage to keep its body in equilibrium, this friction force should be equal to mg sin theta, right? So at equilibrium, basically this force is equal to f of downward force, that is acting on a body. Okay, f down. So this is mg sin theta, and to oppose that force, basically f equal to mg sin theta x on the body. So, yeah, so this is all about circular friction forces. So, depending on the different types of surfaces, the friction force also varies. Okay, so there comes some strategy to solve the problems in the mechanics. Okay, so the first thing about solving the mechanics problem is basically observing the systems, like what are the particles involved in the systems, and what are the factors that we have to consider while solving the problem. Okay. So there are some strategies to solve the problem before directly jumping to the solution. Like uh, there is some strategic way to solve problem. That is firstly you have to analyze the number of particles, analyze number of objects involved in the motion. Okay. So because you might not consider uh, every object in the part of our problem, because some object might just be causing some forces, but that we don't need to consider because we are not considering those particles in our system. So the system is basically some collection of objects and forces that we are interested to keep to analyze and to basically the system is collection of objects and forces that we are interested to analyze. So depending on the different types of system, we need to take the different objects into our consideration, and after that, we need to analyze whether the system is at rest or the objects are moving in some direction or what. Okay, and so let's say there is no acceleration of the system. So what happens? There is no acceleration. So you can say that if there is no acceleration of system. So by the second law, first law of motion, you can say that if there is no acceleration, if there is no external force in the system, so either the system will continue to move in its same direction, or it will, if it is at rest, it will remain at a rest. So okay, so this is basically we have to see if there is no acceleration in the system, then you can go to the equilibrium concept that state that net force acting on every particle of the system is equal to zero, because if there is some non-zero force on any particle of the system, so this will basically cause the acceleration of that particle, and that particle will move out of the system. So but that's not a thing, because if we have considered some system to be at rest, then every particle of that system should be at rest. So that means every individual particle should have net force acting equal to zero. So we need to analyze every particle individually, and we analyze that thing by making some FBD. Okay, So what happens in an FBD? So FBD is basically free body diagram. So what happens in a free body diagram? Firstly, we have to consider the body, and firstly, then after that, we have to consider all the forces acting on a body. So there might be some resistance force, friction force, normal force, or you might say force due to gravity, some external force, or whatever different forces. Some object might be pulling this object, so that is also a force. Some tension force might be there because of some rope, because of some rope pulling this object. Okay, so this is basically consideration of the NVD that you need to consider. And after that, you have to write the equation of the motion for that body and solving those equations to finally come to the final answer. So this is some steps or strategic way to solve the mechanics problem. So the first thing I would say about approaching the problem. So the first thing is to read your question carefully and read what are the forces that are involved. If there is some strings or some string, there might be some forces. Okay. So yeah, that is a thing. And the rest of the strategies we'll see by solving the problems because it might not be possible to simulate all of once because different problems need different solving strategy and so yeah, we'll observe them by solving the questions. Okay, so if we finally move to some of the problems of our exercise, so we'll try to figure out some questions and we'll try to implement our concept by solving those two problems. Okay. Yeah, so first question read करते हैं हम. Yeah, so first question basically state that yeah. So first question state that you have to just give the magnitude and direction of the net force acting on a body. Different you are given different condition of the body and you have to say different forces acting on a body. Okay. Yeah. So this is a good question to basically strengthen your concept about analysis of force acting on a body. Okay. So let's say a drop is falling with a constant speed. So uh, since a drop is falling at a constant speed, okay. So you know that a drop is falling at a constant speed, so net force acting on a body should be equal to zero. Okay. So this is a simple way because it is asked you have to tell about the magnitude and direction of the force. Okay, so magnitude we can say that equal to zero, and if there is no force, so there is no meaning of direction. Okay. Yeah, so this is zero, and then given that a car of mass 10 grams floating on a water. Okay, so let's say this is a cork and this is floating on a water. Yeah, so let's say this is floating in this way in a water. Okay. Sorry, let me redraw this again because it got some clumsy. Yeah. So let's say this is object and yeah. So let's say this is floating in a water. So again, since the cork is floating in a static way and it's not moving in any way, so again, the net force acting on a cork is also equal to zero because there is no acceleration of the body, right? And third is again, a kite is skillfully held stationary in the sky. So again, since the kite is held stationary in the sky, so all the forces that are involved in this in this condition basically would be result in a net force zero because only then the kite can be in a stationary in the sky. Okay. These forces might be the string force that is holding the kite and some weight of the kite there and some air resistance force. So these three forces basically make the net force equal to 0.7. So that's why this is held stationary in the sky. Okay. And the third is given a car moving with a constant velocity of 30 km per hour on a rough road. Okay. So since the car is moving on a rough road, so आपको लग सकता है कि इस पे फ्रिक्शन फोर्स लग रहा है क्योंकि रफ रोड पे मूव हो रही है एंड रफ रोड पे हमारा फ्रिक्शन होता है बट दिस इज नॉट द केस बिकॉज इफ यू ऑब्जर्व द फर्स्ट लाइन of the question, so Basically, it says that the net force acting on a car equals to zero. Okay, I mean, the first paragraph, first word of the question is saying that the car is moving at a constant velocity. So the question constant velocity term itself signifies that the net force should be equal to zero. So since the net force is equal to zero, so there will be a friction force in a backward direction, but there might be some engine force or the pulling force that is keeping this that is also applying in a forward direction to make the net force acting on a car equal to zero. Okay. Yeah. So and the last part is a high-speed electron that stays far from all the material object and free of electric and magnetic field. Okay. So since this is given that the electron is free from electric and magnetic field, so why is it stated that it is free from electric and magnetic field? So because the electron is basically a charged particle and अभी आप कमिंग चैप्टर्स में पढ़ोगे कि चार्ज पार्टिकल पे बेसिकली एक फोर्स लगता है ड्यू टू द प्रेजेंस ऑफ इलेक्ट्रिक एंड मैग्नेटिक फील्ड दैट इज बेसिकली अ कूलॉम फोर्स और Coulomb force or bites. There is some magnetic force that also act on the electron due to the presence of magnetic field. So, but in this case, it is given that there is no electric or magnetic field. So, the net force due to the presence of charge is equal to zero, and also since the electron is present in a free space, so basically the space is free. So that means that there is no gravity as well in the space. So you can again say that the net force on the electron is also equal to zero. Okay. So basically, in this question, if you observe carefully, they're basically given some conditions to analyze your concept of equilibrium because the object are in equilibrium in some way. Like some objects are moving on the rough road, still they are maintaining the constant velocity. So you can get some estimation that there might be some another reaction force that is opposing that retarding force to make the object moving in a constant velocity. Okay. Yeah. So we'll move to the next question. So the next question is a pebble of mass 0.05 kg is thrown vertically upward in the direction and magnitude of the net force on the pebble during the upward motion and during the downward motion and at the highest point where it is momentary at a rest. Do your answer changes if the pebble was thrown at an angle of 45 degrees with a horizontal direction? Ignore the air resistance. Okay, so since this is given that you have to ignore the air resistance, okay. So let's say this is some pebble and you throw it in upward direction, and since it is there is no resistance force, so there is no downward force, there is no retarding force acting on a body, but if you observe carefully, it is not mentioned that the table is thrown in a free space. So that means you have to consider the gravity in this question. Okay. So if you remember carefully, the gravitational force is always acting in the downward direction because the acceleration due to gravity is always acting in a downward direction, right? So the best thing about this question is the gravitational force doesn't depend on the condition of the body, whether the body is moving in the upward direction or downward direction, or it is static. If the object is in the space of gravitational field, the gravity force will always act in the downward direction. Okay, so whether it be a upward motion or whether the pebble is moving in a downward direction or whether the pebble is at rest at the highest point. Okay, so whatever be the condition, the rotation force always act in a downward direction. Okay, so the force of the gravity always act in a downward direction, and this magnitude is equal to m. This magnitude is basically equal to mg, where m is the mass of the body and g is the acceleration due to gravity. Okay. This mass is equal to 0.05 kg. So if you take g equal to 10 approximate, so the force of 0.5 Newton acts on a body at every point. Okay. So yeah, so the force of 0.5 Newton at every point on the body, and this direction is in the downward direction, right? And the last part says that do your answer changes if it was thrown at 45 degree. Okay, so if you have thrown it in the 45-degree direction, so its motion will be something like that, which is a projectile motion. So जो कि अपने kinematics, that is मोशन ऑफ द ऑब्जेक्ट चैप्टर में पढ़ा होगा कि प्रोजेक्टाइल मोशन होता है जब किसी ऑब्जेक्ट को किसी इंक्लिनेशन पे थ्रो किया जाता है ओके सो दैट इज द केस बट सो the thing about this question is that the gravitation force doesn't depend on the way you throw the object, whether you throw in a straight upward direction or you throw the object in a horizontal direction or you throw in some random direction. So in every case, the gravitational force always act in a downward direction. Okay, so at every point of this projectile motion, the gravitational force always act in a downward direction. All right. So yeah. So yeah, even at a highest point, the force of the gravity is acting in a downward direction. All right. So we'll move to the next question that states that magnitude and direction. Again, you have to tell about the magnitude and direction of the net force acting on the stone of mass 0.1 kg. Okay. So it gives some condition like the stone is yeah. So it is given that the stone is just dropped from the window of the stationary train. Okay. Since the stone is dropped from the window of the stationary train, so let's say this is some window and you throw it. This is some stone and you throw it outside of the window. Okay. Let's say this is some compartment of the train. Okay, let's say this is some compartment of the train and you throw it out of the window and train is also at a stationary. Since the object is out of the train now, so it has no metal in the train. Means it has no relation with the train of what train is doing. The stone will perform its own motion, so the only force will act on a downward direction, that is mg force. Okay, so this will act on a body, and the second part says that just after it is dropped from the window of the train running at a constant velocity of 36 kilometers per hour. Okay. Again, so in the first case, the force will act equals to mg. So mass is being 0.1 kg, and if you take gravity equals to 10 meters per second square, so this will be equal to 1 Newton. Okay. If the object is if the train is running at a constant velocity, so even if the train is running at a constant velocity, the only force act on a stone is force due to the gravity, right? So yeah. So again, the force of 1 Newton will be acting on the body because there is no force involved because the train is moving at a constant velocity. Okay. Just after it is dropped from the window of the train that is accelerating at a 1 meter per second square. Okay. So if you observe carefully, you'll see that what is asked in the question. So the question is asked, the stone is thrown out of the window of the train. Okay. Since it is given that just after it is dropped from the window of the train. So if it is dropped out of the window of the train, it has no connection with the train, right? It doesn't it hasn't to do anything whether the train is accelerating or it is at rest. If the stone is moving under the gravity, it will only consider its own motion. So again, the only force acting on the stone is the force due to gravity, and this is equal to 1 Newton. Okay. And the last part is a line on the floor which is accelerating at a 1 meter per second square, and the stone being at a rest relative to the train. So you have to observe one thing, that is stone is at rest relative to the train. That means if you observe by standing inside the train, okay, so you will find that the stone is at rest. Okay, so at a moment you might think that the stone is at rest, so the net force acting on the body, the stone is equal to zero. But for an observer that is standing out of the train, okay, but for an observer, if it is seen from the out of the train, okay, so what will he observe? you will observe that since the train is moving with the acceleration of 0.1 meter per second square, okay, uh, uh, sorry, the acceleration of the train is 1 meter per second square. So the external observer will say that the train is moving at a 1 meter per second square, and the stone is also moving at a 1 meter per second square. So there must be some force that is driving this stone also forward with a 1 meter per second square. Okay. So the net force acting on the stone at this moment is equal to 0.1 into sorry. Yeah. So again, the force acting on the body is equal to 0.1 into 1, that is equal to 1 Newton. Okay. Because even if from the train frame the stone is at rest, but for an external object, the stone is moving forward direction. And if you say about how this force is acting on the body, means how this means आपको लग सकता है कि कोई ऑब्जर्वर कोई भी मीन्स कोई पर्सन इस स्टोन को मूव नहीं कर रहा है, कोई स्टोन जैसा है जमीन पे पड़ा हुआ है तो उसे मूव कौन कर रहा है 1 मीटर पर सेकंड स्क्वायर से। तो अगर आप ऑब्जर्व करो तो ये ट्रेन की सरफेस रफ है थोड़ी। ओके। सो बेसिकली this rough surface provide a friction force to this stone. Okay, so the same friction force basically drive this stone to the forward direction, that is with 1 meter per second square. Okay, so this friction force is basically causing the motion to the stone in this space. All right. So yeah, that is about this question. And if we move to the next question, so the next question says that one end of the string of length L is connected to the particle of mass m, and other to the small peg on a horizontal level. If the particle moves in a circle with a speed v, the net force acting on the particle towards directed towards the center is. Okay. So basically, the case is here that this is some center, and you are moving. Uh, Basically, this thing is tied to this peg on a horizontal table, and you are basically moving this stone in some circular motion. So basically, this circle is in a horizontal plane. Okay. So let's say the circle is in some this way. Okay. The observer is means the object is performing the motion in this circle. Okay. This is basically top view of the table. Okay. This is basically top view of the table. Okay. So, so you have to tell about the net force acting on the body directed towards the center. Since the object is moving with some constant velocity v, okay, and since this is tied to the some string, एक ये string से बंधा हुआ है particle, तो of course एक center के लिए force चाहिए जो कि center की तरफ directed होगा. So this is the basically centripetal force, and this magnitude is equal to mv square by n. And how does this force come? Means it might be hard to visualize what is providing this force to the ball. So if you think this ball is tied to the string, okay. So basically, this string is applying some tension force on this body, and whose magnitude is equal to this mv square by L. So the same tension force is providing the centripetal force. Okay, so that force T equals to this mv square by L. Mv square by L is basically acting on this stone. Okay, yeah. So this is about this question, and let's move to the next question that said that a constant retarding force of 50 Newton is applied to the body of mass 20 kg moving initially with a speed of 15 meter per second. How long does the body take to stop? Okay. चलिए try that. So the object is moving with a constant velocity of 15 meter per second. Okay. So since the force is acting is equal to constant force is acting on the body, so this is simple to analyze. Like Since the force is given, so we know that force is equal to mass into acceleration. Where so if you find the retardation, so this is equal to force by mass. Okay, because the force is acting in the opposite direction, so this is basically causing the some retardation. Okay, so this retardation is equal to 50 divided by 20. This is equal to okay. So sorry for some disturbance. Okay, so what we did in this part is basically we tried some to find some retarding acceleration at first. So we found a retarding acceleration that is causing the retardation of this body, and this is equal to force by mass. So this is equal to 2.5 meter per second square. Okay, and after that, since there is a retardation acting on the body, and finally the body comes to the rest, so finally velocity is equal to zero, and initial velocity is given equal to 15 meter per second square. This is per second. And so time is basically equal to putting v equals to zero and u equals to 15 meter per second. So time is basically 6 seconds. Okay. Yeah. So this is about this part. Uh, I'll be continuing in a 1 minute. Okay, so yeah, till that time you can read the next question. I'll be just back in a 1 minute. Okay. Yes. So we'll move to the next problem now. And yeah, so we are coming to the problem number 6. Okay. So this says that a constant force acting on a body 3 meter of mass 3 kg and it changes its velocity from speed from 2 meter per second to 3.5 meter per second in a 25 second. Okay. So you have to tell about the motion, direction of the motion, and it is said that the direction of the motion of the body remains unchanged, right? So what does this means that the force basically acts in the direction of the motion of the body. Let's say the body is moving in this direction, and we can conclude that force is also acting in this direction because only then the direction of the body will remain unchanged, right? So yeah. So this is about the force and to find the acceleration of this body. So acceleration is equal to uh, v minus u divided by time taken. Okay. So this is equal to 3.5 minus initial velocity is equal to 2.0 meter. So and this changes in a time of 25 seconds. Okay. So yeah. So this acceleration comes to the 1.5 divided by 25. Okay. Which is equal to 0.06 meter per second square. Okay. So this is the acceleration that is caused by the force. Okay. So if you have to tell about the magnitude of the force, so this is equal to force is as equals to mass into acceleration. So as equals to mass is given equal to 3 kg. Okay, 3 into 0.06. So this is equal to 0.18 Newton force. Okay, so this is the force acting on a body, and this is the direction of the this is in the direction of the motion of the body. Okay, so that's about this question. And if we move to the next question, so it is given that a body of mass 5 kg is acted upon the two perpendicular forces of magnitude 8 Newton and 6 Newton. Give the magnitude and direction of the acceleration of the body. Okay. Let's say in this problem, okay, so this is some body and this is acted upon two forces. These are the two perpendicular forces. So let's say this is a 8 Newton and this is a 6 Newton. Okay. So you have to tell about the resultant of these forces. So the resultant force would be acting in some this direction. Okay. And this would be a some angle theta with a horizontal. Okay. So vector sum by the sum of the vectors, you know that the resultant of these two vectors is equal to 6 square. plus 8 square, because these two are perpendicular to, so cos 90 is equal to 0, so we are left with only a square plus b square. So this comes to the 10 Newton, and so yeah, this is the 10 Newton force, and if you define this angle theta, then tan theta is equal to, this tan theta is equal to perpendicular upon base. So this is perpendicular and this is base. So 6 by 8. Okay. So this basically comes to the theta equals to this this round off equals to theta equals to 37 degree, I think, because tan 37 is equal to 3 by 4. So yeah, that's it. So the resultant force is acting at angle of 37 degree with the horizontal, and its magnitude is equal to 10 Newton. Okay. So this is about this question, and if we find about third 4.8 question. So a driver of three-wheeler moving at the speed of 36 meter per second, kilometer per hour, sees a child standing in the middle of the road and brings his vehicle to the rest in 4 seconds, just in a time to save the child. What is the average retarding force in the vehicle? And the mass of the three-wheeler is 400 kg, and the mass of the driver is 65 kg. Okay. So since the mass, the driver and the vehicle are moving together, so मास नेट मास नेट मास इक्वल्स टू कितना हो जाएगा 400 प्लस 60 400 प्लस 65 हो जाएगा सो दिस इज इक्वल 465 न्यूटन हो जाएगा ओके एंड सिंस 465 न्यूटन हो जाएगा एंड since it is given that the driver manages to stop the vehicle in 4 seconds, just to stop the just to avoid the accident. Okay, so that means there is some retardation acting on the vehicle that helped to reduce the speed of the vehicle from 36 kilometer per hour to 0 kilometer per hour in just 4 seconds. Okay, so initially speed u equals to, so u equal to 36 kilometer per hour. So this is in a meter per second is equal to what happened? This will be equals to 10 meter per second, right? Because we multiply by 5 by 18 to convert in a meter per second. Okay. So this is the case. So 10 meter per second. So if we calculate about the retardation, so retardation will be equal to 0 minus 10 divided by time in which the manages to stop the vehicle. Okay, so it is given that time is 4 seconds. So if you divide by 4, so the retardation comes to 2.5 meter per second square, and negative sign basically indicate the direction of the retardation, that is opposite to the direction of the motion of the vehicle. Okay, yeah. So this is the retardation, and if you come to the force acting on the body, so force would be equal to 465 into 2.5. Okay, so this comes if you calculate, so this comes equal to 1.16 into 10 to the power 3. Yeah. So I think on calculating, let me verify this once again. So this is 1.465 into 2.5. So yeah, so this much force act on this much of force act on the body to stop the collision. So if we come to the next question, that is 4.9. So it says that a rocket with a lift mass of 20,000 kg is blasted upward with an initial acceleration of 5 meter per second square. Calculate the initial thrust or the blast, initial thrust of the blast. Okay. So okay, so if you draw about FBD of this rocket launcher, so let's say this is the rocket launcher and this is moving with an acceleration of 5 meter per second square. Okay. And if you observe carefully, there is some gravity force also acting on this body. Okay. So what happens? G is also acting. So if you consider G equals to 10 meter per second square, and if we analyze the net, uh, okay, one net, since the gravitational force is acting upward direction, so there must be some thrust force, and that that would act on an upward action to give it a acceleration of 5 meter per second square. So if we if we write the equation of means the force equation according to the second law of Newton, so this comes to F thrust, okay, F thrust minus F of gravitational. This is equal to mass into acceleration. And this acceleration is basically 5 meter per second square acceleration that is acting on a body. Okay. So F thrust comes to be equal to F gravitational plus mass into acceleration. All right. So F gravitational is basically equal to mass into gravitational force. So mg plus m into a. So this comes to be equal to F thrust equals to capital A into G plus A. Okay. So this is the case, and if we substitute the value, so this finally comes to equal to 20,000 into 10 plus 5. So 15 into 20,000. So this comes equal to uh, 3 into 10 to the power 5, 10 to the power 5 Newton, I think. Yeah, so this much amount of the force, this is the initial thrust that is required to be provided to move it in the upward direction with acceleration of 5 meter per second square. All right. Yeah, so this is about this question, and if we move to the next question. Okay, so we are moving to the 4.10. Uh, just 1 minute, sorry for the disturbance. Okay, so we'll be moving to the next part, and that is 4.10. So if we read about the question, so it says that a body of mass 0.4 kg is initially moving with a constant speed of 510 meter per second in a knot is subjected a constant force of 8 Newton directed towards the south for 30 seconds. Take the instant of the force applied to be t equals to 0 and the position of the body to be x equal to 0 and predict its position at t equals to minus 5 seconds, 25 seconds, and 100 seconds. All right. So let's say this is the coordinate system and our body is in this direction, and it is given that initially moving with a constant speed of 10 meter per second to the north. So basically, it is moving in this north direction, and 8 Newton force act along the south direction. So firstly, we try to find the retardation that is caused by this 8 Newton force. So this is equal to 8 divided by mass of the body. So mass of the body is 0.4. So this is causing the retardation of 20 meter per second square. So we write it minus. So yeah, so this is the retardation acting on the body. So you have to tell about the position of this body at t equals to minus 5 seconds. So you might be confused what is mean by the negative time. So actually, the question is framed in this way, like the particle would be somewhere at this point, and after 5 seconds, that means, let's say this is the instant of the time t equals to minus 5 seconds, and this is the t equals to 0. Okay. So after you can say that after 5 seconds of this point, after 5 seconds of this point, the particle reached to this point. So you have to calculate this distance. since it is given that force start acting on the body after t equals to 0, okay. So means whatever be the time before t equals to 0, the object will be moving at a constant speed. So uh, finding the distance at t equals to -5, let's say it was some x distance. So we can say that in a 5 second it has moved this x distance, okay, and this x distance should be equal to constant velocity, that is equal to 10 meter. Okay, so the particle would be somewhere here at 0 comma -50, okay. In a coordinate system the particle would be somewhere at 0 comma -50. That's why in a 5 second it has covered this 50-meter distance to reach the origin, okay. Yeah, so this is about this part, and if we talk about t equals to 25 second, okay. Yeah, so since we have already obtained the retardation that is equal to 20 meter per second square, and t equals to 0, the velocity is equal to 10 meter per second square. So we can directly put it in the equation of the motion, that is s equals to ut plus half at square. So yeah, so if we put substitute the value in this direction, so we have to find the distance, and we are given initially that uh, velocity speed equals to 10 meter per second, and you have to calculate after 25 seconds. And the acceleration is in negative direction, so we'll write it by negative sign, and 1 by 2 into this is equal to 20 into you have to tell about after 25 seconds, so this is equal to 25 square. So if you calculate this, so 25 to 10, 250, and 10 into 6250 minus 250. So this is equal to minus 6,000 meters. So again, the particle load is somewhere on the y-axis, whose y coordinate is equal to 0 comma minus 6,000 meter. Okay, so this will be the position. Okay, and you have to tell about its position at t equals to 107. Okay, so what happened after, since it is given that the force act on a body for 30 seconds. Okay, so what happened for the first 30 seconds, out of the 100 second, means if you are considering for the 100 second, then uh, okay, so for 100 minus 30, that is equal to 70. So that means for the 70 second, the particle moves at a constant speed, and for the 30 second, the particle moves under the retardation. Okay, so that firstly you calculate what is the velocity after 30 seconds. Okay, so we after 30 seconds, so this will be equal to uh, v equals to u minus 80. Okay, so this is equal to 10 minus 20 into 30. So this comes equal to 5 590 meter per second. So that means for the 30 second, it will be moving under the retardation, but after the 30 second, it will be moving with a constant speed of 590 meter per second. Okay, so what happens? We have to find the distance that it will cover in a 30 second. Okay, so by using the same formula, that is s equal to ut plus half at square. So s equal to 10 into 30 minus 1 by 2. Retardation is 20 meter per second square, and time is 30. Okay, so this comes as equal to 300 minus this comes equal to minus 8700 uh, 8700 meter. Okay, and This is the distance it cover in retardation motion, and the distance it cover in a uniform motion because after 30 seconds up to 30 to 100 seconds it moves with a uniform velocity of that is a uniform velocity of 590 meter per second. Okay, so for the 30 for the next 70 second it moves with a constant velocity of this much. Okay, so this distance covered equals to 590 into 17, and we write it with a minus sign because it is moving in the negative direction, negative y direction. So this comes equal to 41300 meter. Okay. So if you have to find the net distance it covered in us, so this is equal to the sum of these two distance. That is uh, this distance and this distance. So this comes equal to over one. So this basically comes 50,000 meter, or you can say that 50,000 kilometer. Okay. So this is the whole about this question, and if we move to the next question, so yeah, so we'll be moving to the 4.11 question. So it is given that a truck starts from the rest and accelerate uniformly at 2 meters per second square, and at equals to 10 stone is dropped. A stone is dropped by a person standing on the top of the truck, 6 meter high from the ground. Okay, so what are the velocities and acceleration of the stone at t equals to 11 seconds? Okay, yeah. So if you consider about the motion of the stone, it has basically two component. Okay, because let's say this is the truck. Okay, stone is somewhere there. Okay, so what happens? The acceleration, the truck is accelerating at 2 meters per second square, and t equals to 10 seconds. A stone is dropped. Okay, so at t equals to 10 seconds, there would be some velocity in the horizontal direction because the stone is lying over the truck, and the truck has gained some velocity in that 10 second. Okay, so if you consider that velocity, so that velocity comes equals to plus 80. Okay, so this is basically equal to 0 plus uh, 2 into 10. So this is equal to 20 meter per second. Yeah, so by the end of the 10 second, this much is velocity possessed by the stone. Okay, and you have to tell about at t equals to 11 second, what is the velocities of the stones. Okay, so that means since the stone is dropped at t equals to 10 seconds, so for the next 1 second, it will perform the motion under the gravity. Okay, yeah, so basically the stone would be behaving something like this. This is moving under the gravity, and this is some horizontal velocity possessed by the stone that is equal to 20 meter per second, 20 meter per second. Okay, so this is the Vx velocity due to its presence on the truck. Okay, and for the 1 second, what would be the, yeah, so for the 1 second, that is from 11 to, means because the stone is dropped at a t equals to 10 second, and we have to find at t equals to 11 seconds. So for 1 second, it has moved under the influence of gravity. Okay, so the velocity gained in a 1 second v equals to u minus gt. Okay, u minus gt, and u equals to 0. So here we have to take care that we are considering the motion in a vertical direction. Okay, not the horizontal direction, because the horizontal direction is independent of the vertical direction, because the gravitational force only act in a vertical direction. Right, so and this comes to equals to minus If we consider acceleration of gravity equals to 10 meter per second square, so this is equal to 10 meter per second because you have to calculate for 1 second of the 1 second of the time. Okay, so basically these are the two velocities possessed by the stone, and there should be some velocity v. Okay, vy. So this is same equals to vy. Okay, this is the vy, and the vx is already calculated, that is equal to 20 meter per second. Okay, so what you have to tell about the question? If you have to tell about the net velocity, so net velocity would be the square root of vx square plus vy square, because these two are perpendicular velocities. Okay, so this is equal to uh, 20 square plus 10 square. Okay, so this comes out to be equal to 22.36 meters per second. And you also have to tell about the direction of the acceleration at equals to 11 seconds. So since the stone is detached from the truck, so there is no relation between the acceleration of the truck and acceleration of the stone. But stone has only one acceleration, that is the acceleration due to the gravity. All right. So the only acceleration that is acting on the stone is due to the gravity, and this is equal to 10 meter per second square. Okay. So this is about this part of the question. Okay. And yeah, if we move to the next question. So next question is about mass 0.1 kg is hung from the ceiling of room by the string of 2 meter long. Is set into the oscillation, and the speed of the bob at the mean position is 1 meter per second square. 1 meter per second. And what's the trajectory of the bob if the string is cut? Uh, when the bob is at one of the extreme position and one of the mid position. Okay, so you just have to tell about the trajectory of the motion. So this is an interesting question because you will analyze something about what we call uh, the motion in the circular direction, because the bob perform the motion in some of the trajectory that can be considered as some kind of a part of circle. So if the bob has sufficient speed, then it will be performing the motion. Like it would be some oscillatory motion, and let's say these are the extreme position of the bob. All right, and this is the mean position, and let's say it is given a motion in this direction at first. Okay, so this is 2 meter. Okay, so you just have to tell about the trajectory of the motion of the bob. So if you know at the extreme point, the bob is at rest, because how you define the extreme point? The extreme point is the point at which the bob cannot move the further. Okay, and the bob cannot move the further only when the velocity has been equal to zero, because if there is a velocity, it will keep on moving. Okay, so this is about the extreme position, and the velocity is equal to zero. Okay, and it is said that what is the trajectory if the string is cut at this point. Okay, so that means it has been cut at this point. Okay, since the bob is already at rest, and if the string is cut, so the bob will be falling freely under the influence of the gravity. Okay, so its trajectory would be the straight or vertical line. Okay, because after cutting the string, there is no other force that is acting on the bob except the gravitational force, and the gravitational force would influence the bob to move in a vertical direction. All right, and the interesting part is about the mean position. Okay, so you know the bob has a net velocity in a horizontal direction at the mean position, because at the mean position the velocity of the bob has a only horizontal component, because it is the maximum at that case, and the maximum is only when there is no vertical motion, because the string and the motion of the bob are perpendicular to each other. Okay, so this is the velocity possessed by the bob, and if the string is cut at this point, so what would happen? Uh, the gravity would be acting something like this direction. Okay, so you can estimate this motion as a kind of projectile motion uh, because the bob has initial velocity in the horizontal direction, and this velocity would be equal to what is 1 meter per second. Okay, so this would the velocity, and there is a one acceleration acting in the downward direction. So this horizontal component will keep on pushing the bob in a horizontal direction, but this vertical component keep on uh, pulling the bob in a downward direction. So its trajectory would be something like this. Okay, this would be some trajectory of the bob, and this is same as a trajectory in a projectile motion when the bob has some velocity in a horizontal direction as well as the acceleration acting in a downward direction. All right. Yeah, so this is about the trajectory of the bob in these two cases. Okay. So so if we move to the next question, that is, so this question state that this question state that a man of mass 70 kg stands on a weighing scale in a lift which is moving upward with a uniform speed of 10 meter per second downward and upward. So you just have to tell about we just have to tell about the reading of the machine in these different cases. All right. So, so firstly, you have to tell about you should be familiar with working of the weighing machine. Okay. So what happens if this is the weighing machine and a person is standing over this weighing machine? Let's say, so if it is if he is standing on this weighing machine, then what happens? The weighing machine applies some normal reaction force on this man, and the man has some gravitational force acting on downward direction as well. So basically, the normal reaction force is that the weighing machine apply on this man is same as the reading. Okay, so basically you have to calculate about the normal reaction force in each case. Okay, so there might be a case when this is accelerating upward, then you have to draw about the FPD of the body to consider about that acceleration as well. Okay, so what happens? Uh, Normal reaction force basically tries to balance the man over the platform. Okay, so since the man remains at a rest related to the ground, related to the lift or lift in which he is standing. Okay, so if you are observing from the frame of the lift, so you will be observing that only lift is accelerating upward, but the man is standing at the same position as it was before. Okay, so what happens if you consider about the activity of the body? So when the lift is moving upward, so what happens? There is some force also required to move the man upward as well. All right. So what happens? This same normal reaction force tries to pull the man upward direction. All right. So we can write the equation of the motion as follow, and minus m equals to m into a, where a is the acceleration for the upward motion. So if it is moving upward is 5 meter per second square, so a equals to 5. Okay. So n equals to m times of g plus a. So this is equal to 70 into g plus a, g equals to 10 plus 5. So this is the force that this would be the reading that would be. So this is the reading that would be when the unit is moving upward direction, because the normal reaction force would be this much during that time. And if we consider about the first part, that is the platform is moving upward with uniform velocity of 10 meter per second square, 10 meter per second. Since the platform is moving with a uniform velocity, there is no external force except the gravitational force on the man. So in that case, the normal reaction force only balances the gravitational force. Okay, so the reading would be same as the weight of the man. Okay. Okay. So when the lift is moving in downward direction, so what happens? There is a net acceleration in a downward direction of the man as well. Okay. So if we write the equation of the motion according to the Newton's law, so what happens? This is the normal reaction force acting upward direction, and this is the mg force in a downward direction. So the resultant of these two forces must be such that this is the acceleration in the downward direction. All right. So n minus mg equals to minus m into a. So why have we written it with minus ma? Because if we consider upward direction to be positive, then gravity is acting in a downward direction. So this is equal to minus sign, and this net acceleration is also in a downward direction. All right. So this is the case, and this n comes equal to m times of g minus a. Okay. So this is equal to 70 into 10 minus 5. So this is equal to 350 Newton. Okay. And the case when the lift starts falling freely, okay, at that instant, what happens? The acceleration is equal to 10 meter per second square because the free fall condition is same. Okay, so this is all about this part of the question, and if you move to the next part of the next question, so we have to work with 4.14. So we are given some graph and we have to tell some, we have to tell the question based on those plot. Okay. So this says that position time graph of a particle of mass 4 kg, and what is the force on a particle for t less than 0, t greater than equal to 4, and t 0 to 4. Okay. And you also have to tell about the impulse at t equals to 0 and t equals to 4, considering only one dimension of the motion. So the motion is only in the straight direction. So you don't have to consider about the 2D direction. Okay. So firstly, we tell about the force on a body. Okay. So if you consider carefully, the graph is given about the position versus time graph. Okay. So if we draw the graph, so okay, just 1 second, let me draw it again. Okay, so this is the initial case, and initially something like this, and after that it moves in this direction, and something like this, and okay, so we have to tell about the force on a particle. So you know that force is equal to mass into rate of change of velocity. Okay, dv by dt. Okay. So if you consider about this part, so you know that dv by dt is basically v of dt, and v is basically dx by dt. Okay. So this is the whole expression for the dv by dt. Okay. So if you consider about this part, so dv by dt is basically uh, sorry, x is always constant. Okay. So dx by dt is equal to 0. So velocity is also equal to 0, and this force is also equal to 0. So for less than 0, the force is equal to 0. Okay. And if you consider about greater than 4 seconds, so again the x is constant. So dx by dt is equal to 0. Okay. So dv by dt is also equal to 0. So the force is equal to 0. Now about this part. So you know that this is the straight line. Okay. And what is the dx by dt of this straight line? So dx by dt of this straight line is basically the slope of this line. So dx by dt is equal to slope of this line, and if you try to find the slope of this line, so this is theta, so tan theta is equal to, this is 3, and this is 4. Okay. So dx by dt is equal to 3 by 4. Okay. So you know that there is a some slope, there is a rate of change of distance, but still the velocity is constant again. So again the rate of change of velocity is equal to 0. Okay. So again the force is equal to 0 for that instant also. So the force is zero for all the instant. Okay. Now you have to find about the impulse at equals to zero and impulse at t equals to 4. So what do you mean by the impulse? So impulse is basically the rate of change of momentum. Okay. So if you consider in this way, so okay, so I'll insert the text box here. So you know that impulse is equals to rate of change of momentum. Okay, or you can say that the total change in the momentum. It is more correct. Total change of momentum. Okay, so at t equals to zero, if you observe just before, so momentum is equal to zero because there is no speed of the object, so momentum is zero, and just after the momentum is equals to t equals to m into v, okay, and velocity is equal to dx by dt, and this is equal to 3 by 4. So m into v equals to mass into velocity, that is equal to 3 by 4. So this is equal to 3 meter per second. This is equal to 3 kg meter per second. Okay, so this is the final momentum. So the impulse J is equal to P final minus P initial. So this is equal to 3 minus 0. So this is equal to 3 kg meter per second. Okay, so at T equals to 4, again the initial momentum Pi equals to m into v, and this is equal to 3 kg meter per second square, kg meter per second. Because the object is moving with a uniform velocity, so its momentum doesn't change because velocity is also constant. Okay, and just after the velocity becomes zero, so momentum is equal to 0 kg meter per second. Okay, so delta P is equal to impulse equals to 0 minus 3. So this equals to minus 3 kg meter per second. Okay. So this is all about this question. Okay. So I'll be continuing the remaining part of it after some time. So I hope we have learned a lot of new concepts and new facts about laws of motion and how to deal with the activities of the body, and that's all. Okay. So we'll be applying more principle and more concept in the remaining questions. So yeah, we'll see you again after some time. All right.